Welcome back to Knowledge Bytes and our AWS AI Practitioner journey. So, in previous episode, we learn about the neural networks and learn how AI systems are inspired by the human brains. But have you ever wondered what a neural network is actually made of? But have you ever wondered what a neural network is like? How it is learning the patterns or data? Just like a building is constructed from thousands of individual bricks, right? Neural networks are built from the same tiny computational units that is called the perceptrons. Today we are going to uncover one of the most important concepts in the artificial intelligence. We will learn what a perceptron is and how it works and why it's important, and how is simple concept eventually led to the modern AI systems like ChatGPT, image recognition system or recommendation systems, and self-driving cars. By the end of this video, you will learn about the you will learn about the fundamentals of fundamental building block of behind the neural networks. Right? Let's get started. Now, so how does AI make decisions, right? Let's begin with a simple question. Imagine you are getting ready to leave your house, and you will look outside and ask yourself, is it cloudy, or is rain predicted, or is it windy? Your brain evaluates all these signals and makes a decision, right? Should I carry an umbrella, or should I leave it at home? Although it feels natural to us, this is actually a decision-making process. AI system works in the similar way. They receive multiple pieces of information, evaluate their importance, and combine them together, and then produce an output. So the simplest unit capable of performing this process is called the perceptron. You can think of perceptron as the smallest decision making the inside a AI system. Let's now, what is a perceptron? So what exactly is a perceptron? A perceptron is a simplest form of an artificial neuron. It was introduced in 1957 by Frank Rosenblatt. Its purpose was to mimic the decision-making behavior of biological neurons found in the human body. At high level, the perceptron performs three basic steps. It receives inputs and it processes those inputs. Then it produces the output. So basically, input and the processing and output. That's very simple, right? Yes, this is simple idea became the foundation of neural networks, deep learning, and modern artificial intelligence system. So without perceptron, there would be no neural networks, right? And without neural networks, there would be no modern AI system, right? So now let's autonomy of a perceptron. Let's look at the components that makes up perceptron. So first component is we have inputs. The inputs represents information entering the system. For example, temperature or rain predictions or credit score or income or any data which helps make decisions, right? The next one is weights. Weights determines how important each input is. Some inputs matter more than others, right? After applying the weights, the perceptron calculates the weighted sum. Then it adds something called bias. Finally, the results passes through an activation function. The activation function decides whether the neuron should activate or produce an output. The final result is output decision. The entire process happens in the milliseconds inside the AI systems. That's where we cannot recognize this. So everything happens inside within the milliseconds. Right now, understanding the weights. So weights are one of the most important concepts in machine learning process. Think of a weights as important scores, right? So let's go back to our umbrella example. Suppose you consider three factors: the rain predictions and cloud cover, and wind speed. So these are the three predictions you have that. And which one of the most the matters most? Probably rain prediction. If the weather app says that okay, there is a 90% of the chance of the rain, then that's strong indicator, right? Could cover the cloud cover is useful, but slightly less important, right? And same way the wind speed might matters less, even less, right? So therefore the rain predictions get a higher weight, cloud cover gets a medium weight, and the wind speeds gets a lower rate. So now during training, AI system automatically learn these weights from the data. This learning process is what allows machine learning models to improve over time. Now, how a perceptron make decisions, right? Now let's see how a perceptron actually makes decisions. The process can be broken into 4 simple steps. Step 1, multiply each input by the corresponding the weights. Step 2, add all weighted values together. And step 3, that is add bias, so add the bias value. Step 4 is pass the results to the activation functions, and the activation function determines whether the neuron should be activated or not. If the result exceeds a threshold, the output might be 1. If it does not exceed the threshold, the output might be 0. So this allows the perceptron to perform binary decisions such as yes, no. So approve or rejected, like loan approval, loan application can get approved or rejected. It's a binary decisions. Or whether the email is spam or not, it's a binary decision. The same way whether the fraud or the suspicious transaction, the fraud or not fraud, that's right. So although modern AI systems are much more sophisticated, they still rely on the same fundamental principles, right? So let's take a real world example, loan applications, loan approval process, where we most of the time have learned about this one, right? Let's see how a perceptron can be used in the real world business scenario. So imagine a bank evaluate a loan application or evaluating the loan process through the loan process. The system receives several inputs like annual income, credit score, or existing debts. So each factor receives a different weights based on the importance. The strong credit score might positively influence the decision, right? The same way, the high income might also increase the approval chances, but whereas large existing debts may reduce the likelihood of the approval, right? It's a negative. The perceptron combines all these factors and produces the decisions whether the loan should get approved or not. It's approved or not. So our loan should get rejected or not. So it's a binary decisions. While real banking systems much more advanced model today, so the core concept remains the same. So multiple inputs are evaluated to generate the decisions, so basically. So now comes to the bias. What is the bias, right? We have discussed inputs and the weights. Now let's discuss about the another critical component, which is called bias. Bias can be thought of as a starting preference. It's a preference basically. Imagine a teacher grading an exam, right? Okay, a teacher is just grading an exams, and our teacher is evaluating the question papers. Let's say before reviewing any answer, a teacher may already have certain expectations, right? Bias works similarly. So if she has the expectations, meaning that's a bias, right? It shifts the diffusion threshold. Without the bias, the model can become too rigid. So bias provides flexibility and allow the perceptron to learn more effectively. Think of this way. So weights determines importance, bias adjusts flexibility, and together they help the model make better decisions, right? Now let's go to the limitation of the single perceptron. So perceptrons are powerful, but they have limitations. A single perceptron works very well for the simple linear problems, right? For example, the basic classification tasks or simple decision boundaries. Or however, many real world problems are far more complex image recognition systems, or speech recognition system, or language understanding, or self-driving vehicles, or medical diagnosis, or fraud detection services, or these problems are often non-linear, right? So single perceptron cannot solve these complex problems, complex linear problem, non-linear patterns, right? These limitations become one of the biggest challenges in earlier AI researchers. So fortunately, researchers discovered a solution. Instead of using a one perceptron, they combined many perceptrons together, and that led to the creation of the neural networks. That's where started the neural networks, right? So now perceptron, we learned about the neural networks, and now we learn about the perceptron versus the neural network. Let's compare a perceptron and the neural networks. So let's look at these diagrams. The perceptron is a single artificial neuron. A neural network contains many interconnected neurons. A perceptron makes simple decision, right? The neural network can learn complex patterns. A perceptron is a building block, but a neural network is a complete structure built from these blocks. Think of it like this. So one brick cannot create a skyscrapers, right? So but thousands of the brick working together can build something extraordinary. That's similar. One perceptron cannot power ChatGPT, but millions of perceptrons connected together can create incredible intelligent system, right? So now let's come to our AWS exam perspective. How this topic is going to be covered? This perceptron is going to be covered in AWS exam. Now let's test your understanding level 2. So which statement best describes perceptron? That's a question. Answer A, the option A gives that database used to store AI models, and B says that simple artificial neuron that process inputs and generate the outputs, and C says that cloud storage services, and D says that a type of AWS region, right? So let's eliminate the answers one by one. The 8 is talking about the storage. The perceptron is not talking about the storage, so we can eliminate the A. And the C is talking about C also, it's about this cloud storage, right? So and D is talking about the region. So A, C, D, or they are not relevant to the here. So basically the answer B is correct. So a perceptron receives inputs, applies weights and bias, and process information and produce an output. That's where we call the perceptron. But answer B is right? Okay. For AWS AI Practitioner exam, remember this important statement: perceptron equals basis artificial neuron. Right? This concept appears frequently because it forms the foundation of neural networks. Now let's key takeaways. Let's quickly review today's key points. A perceptron is the simplest artificial neuron. It receives multiple inputs and processes them. Right? Weight determines in importance of each input, and bias adjusts the decision threshold and adds the flexibility. A single perceptron can solve simple linear classification problems, and many perceptrons connected together from the neural network. If you understand these 6 concepts, you have successfully mastered fundamentals of perceptrons. Now let's closing. Today we explored one of the most important concepts in the artificial intelligence, that is the perceptron. Although it may look simple, it introduced the revolutionary idea that machines can learn, evaluate information, and make decisions. This simple innovation becomes a foundation of neural networks and deep learning and modern AI systems. Every recommendation engine, or every image recognition model, or every chatbot, and every large language model ultimately built upon this fundamentals of concept. Right? In our next episode, we will dive deeper into the weights and biases and learn how neural networks actually learn from these data. right? Okay, it's one of the most important topic for the understanding machine learning and deep learning. If you found this video is helpful, please like, share, subscribe to continue our AWS AI practitioner journey from the knowledge bytes. Thank you for watching.